Hello and welcome to the session. In this session, we will have a quick overview of some important questions in reinforcement learning. I've divided into two parts, part 1 and part 2. In part 1, we deal with all the important questions which are quite simple. In part 2, we will look more into the complex topics which are the algorithms with respect to reinforcement learning. So these are the various frequently asked questions in this concept of or in this chapter of reinforcement learning. So let's first understand what is reinforcement learning. So basically it's a I'll be in short referring reinforcement learning as RL. So it's a machine learning paradigm that mimics how humans and animals learn through experience. So as humans, see, if I have to learn something, right? Suppose I have to learn machine learning, I interact with the environment. In my case, the environment can be the textbook or the resources which I'm using for study. I receive feedbacks. The feedback can be a reward or penalty. So when I'm learning and I take some kind of an exams, right, the exam can be I may get a good marks, that can be a reward. I can get good a little bit less marks, that can be a penalty. So based upon that feedback, I adjust my learning technique, right? I adjust my behavior. So that's nothing but reinforcement learning. So basically you reinforce learning, right? Suppose a child touches fire. First time it may touch the fire and it understands that it has to avoid it. So basically we learn hereby from experience. In this case, child touching a fire is an example of negative reinforcement. So there are two types of reinforcement learning. RL stands for reinforcement learning, positive reinforcement learning and negative reinforcement learning. So positive reinforcement learning means rewards, which encourages good behavior. For example, a robot gets plus 10 points for reach a goal. So based upon that plus 10 points, you again try to improvise your learning and you play again. So the effect of positive reinforcement is reinforcement. It increases the likelihood of repeating the rewarded action. Okay. So negative reinforcement is the negative rewards would discourage unwanted actions. Right. So a game agent loses minus 10 points for stepping into a danger zone. So once you get that negative point, the agent will learn that it has to avoid this negative outcome. So what's the difference between reinforcement learning with respect to supervised and unsupervised? Let's understand the difference with respect to supervised learning. So reinforcement learning doesn't have any supervisor. That means you don't have any labeled data set. We know about supervised learning where we have a supervisor, we have a labeled data set. The second difference is in reinforcement learning, the decisions are dependent. They're actually made sequential. So when I'm learning a cycle, suppose I'm learning cycling, right? So based upon if I fall, right, based upon my previous experience, I improvise my cycling skills. So basically it is dependent and it is sequential. Whereas supervised learning is decisions are independent of each other. The third one is feedback is not instantaneous. In reinforcement learning, there can be some instantaneous feedbacks. Many times it is a delayed feedback. But in supervised learning, the feedback is instantaneous. In reinforcement learning, the agent action affects the next input. So what happens, whether you got a positive feedback or a negative feedback, based upon that the next action would be determined. Whereas in supervised learning, the output is only dependent upon the initial input. It is not dependent upon any kind of a feedback. There is no feedback mechanism in supervised learning. So in reinforcement learning, no target variables. You don't have any target values or only goal oriented, like you don't have labels, right? But in supervised, you have a target class, right? Either you have to determine that this is a, like let's say this is an apple or not an apple. So you have a target class. So an example of supervised learning is classifiers, which we have learned. Example of reinforcement learning is some of the games like chess, right? Go, Atari games. These are all examples of reinforcement learning. With respect to unsupervised learning, in reinforcement learning, there is a mapping, right, from input to output. But there is no mapping here in unsupervised learning. And in reinforcement learning, we keep getting constant feedback from the environment, but there's no feedback concept in unsupervised learning. We don't have feedback concept in supervised learning as well. We do have, but it is a instantaneous feedback, we can say. So coming to real-time scenario of understanding reinforcement learning, we can take a real-world analogy where a child is learning to ride a bike, right? So here the child is the agent. So we have certain terms that we need to remember: agent, environment. So the child here is the agent. It is interacting with the bike and the surroundings, right? So the surrounding is the environment. So the keywords which we have in reinforcement learning is agent and environment. So if he is pedaling correctly and he is maintaining a balance and is moving forward smoothly, then it's a positive reward. If suppose the child falls, then it's a learning moment. So it's a negative reward. So over time, the child will refine his actions, which are nothing but policies to achieve the goal of riding the bike effortlessly. So some of the keywords which we will be using next in reinforcement learning are agent, environment, positive reward, negative reward, and policies. Policies are nothing but some kind of an algorithm, right, which the child is using to refine his actions of learning. So let's understand the basic components of reinforcement learning. So this is the basic components of reinforcement learning. You have the agent. So with respect to the previous analogy, agent is a child, right? So he is the decision maker. He interacts with the environment and he takes action. The second one is the environment. For the previous example, the child is riding on a road in a park. So the environment there is the park. So basically environment is nothing but the external world where the agent interacts. The third one is the state. So state is basically a representation of the environment at a specific time. So now with respect to time, because it's a sequential action, with respect to time we define something called as states. So it's a representation of the environment with respect to time. The fourth one is the action. Now action is based upon whatever feedback the agent has received. Maybe it's a positive feedback or a negative feedback. The agent will take an action, right? So the possible choices available to the agent at a given state. So basically it is a possible choices. So each action influences the environment and leads to new states and rewards. The fifth keyword is, or the fifth component is reward. So reward can be, as I said, positive reward or a negative reward. Is basically a feedback signal received by the agent for taking an action. And the last one is a policy. The policy will represent as pi. Okay, so basically it's nothing but a strategy which is used by the agent for making that particular action. So these are the key components of reinforcement learning. And there's one more, episode. So episodes are nothing but sequence of states, sequence of actions, and sequence of rewards, starting from the start state to the goal state. Now coming to the characteristics of reinforcement learning. The first characteristic is reinforcement learning is a sequential decision making algorithm. So the agent will make a series of decisions in order to maximize the total rewards. And as I said, you have a delayed feedback. The rewards are not immediate. So one must make some moves in order to get final success or failure. Trial and error learning, right? The agent learns by exploring different actions and the consequence. And you don't have any supervised labels, right? So unlike in supervised learning, here we don't have any label data. You have to learn from experience. And the actions of the agent, they are all interdependent. So one wrong move may cause a failure. So simple way to understand is a grid game. So the agent here is a robot. The robot, and the goal here is reaching the diamond, right? So the robot can move like this. There are different paths through which it can move. So whenever the robot reaches the fire, so it will be a negative reward. It may lose some points. So maybe you have some kind of a positive rewards here. So then he will feel encouraged and he will move forward. So here the robot is the agent, the diamond is the goal, and the agent will be using some kind of an algorithm, which is nothing but a policy, in order to make its move. So basically all these actions what we observe, it is time related, right? It's a sequential decision making method where the actions are associated with timestamps and the actions are ordered as per the timeline. So let's understand the applications. Various applications are there. You can use it in industrial automation, for robotic movements, for resource management in data centers and cloud computing, traffic light controls, personal recommendation systems. We see Netflix recommendations, online advertisement bidding, where we optimize the ad placements for maximum engagement. Many AI games like chess, Go, Dota 2, etc. DeepMind applications like generating programs, images, optimizing machine learning algorithm, autonomous vehicles, finance, healthcare. There are various ways, various applications of reinforcement learning. So coming to the challenges is setting the right rewards is very important. Incorrectly designed rewards can lead to undesired behavior. Absence of a fixed model. There is nothing like a predefined model in reinforcement learning. For example, a game of chess. We don't have a predefined model. Chess may have some fixed rules, but there are various ways through which you can tackle the chess problem. So, and also training a self-driven car, it requires simulation. So basically chess or self-driven cars, they are learning from experiences rather than by going through a fixed model. And partial observability, some weather environments like weather prediction involves uncertainty because complete state information is unavailable, right? So sometimes the environment is not completely there to provide you complete information, so that can be again a problem, a challenge to use. High computational complexity. If you think about games like Go, there's a lot of huge state space. You have a lot of states, so basically our algorithm becomes very complicated and therefore very time consuming, because more possible actions, more training time you need, right? So these are the challenges. So coming to two different terms which we'll be normally using. First, let's try to understand what is a policy. See, as I said, the agent will be using some policy in order to generate the action. So policy can be understood as an algorithm. So the role of algorithm is called as a policy. So basically policy helps to map the states to the action. The policy is like an algorithm which will take the input states, processes it, and suggests an action for the agent. So there are two types of policies, deterministic and stochastic policy. Deterministic means, as the word itself says, it is fixed, right? There is a state and it always returns the same action. So it is kind of pre-mapped. So you have a deterministic action. Coming to stochastic policy function, it's a probability of taking an action, right? So there is a probability that you may take this kind of an action. So aim is to, so the difference here is in deterministic policy, the action taken is fixed, it is pre-mapped. But in stochastic policy, there is a probability that it may take action 1, or there is a probability that it may take action 2. So that comes in a stochastic policy function. So how do you choose a policy? Choose a policy that has better cumulative expected reward over all the other policies. So whichever policy gives you the maximum reward, choose that policy. Coming to rewards. Now rewards are basically used to measure it's measured by system performance. So rewards is something that the environment will produce to the agent. So it maps a set of states to a real number. So normally we use the symbol R to understand reward, and reward depends upon the current state S, it depends upon the action A, and it also depends upon the total state, net state S. So there are two types of reports, or they can also ask you what is total reward and what is total future reward. Now there are two types of rewards, mainly immediate reward and long-term reward. As the word itself says, immediate reward means the environment will immediately deliver the reward after the execution of an action. But long-term reward means rewards are given at the end. So immediate reward basically is since it is immediate, right, it is the sum of the rewards here it is the sum of the rewards from the first move to that particular last move, right? So basically, let's say I am doing some actions like this. I am doing some 5 actions. I am collecting the reward at the state 3. So my rewards at the end of state 3 would be reward from state 1 reward plus the reward from state 2 plus the reward from state 3. So I will be collecting the rewards from the first move to that particular move where I am collecting the rewards. But long-term rewards is the total. I am going to collect the rewards of the current move plus all the other moves, because it is collected at the end. Long-term reward is collected at the end. So I am going to collect the rewards of all the moves. Okay, so that's why this is the formula. The difference in the formula here is, in the first one, immediate reward, GT is the return and RT is the terminal or the final state. So I will be collecting the rewards at the end of that state. But in long-term reward, it is the sum of all the rewards of all the states. So here I am using a term called as gamma. Okay, so gamma is also called as discount factor. Gamma is called as discount factor. So if gamma is 1, then it is close to, then it is a total reward. So this can be asked. So what is total reward is, if gamma is 1, then it is a total reward. If gamma is 0, then it is a immediate reward. So gamma value normally is between 0.8 to 0.9. Now let's do a problem on this. Let us assume that at fifth step the reward is +1. If the discounted factor gamma is 0.7, then what is the discounted reward or utility? Assume that previous steps rewards till the fifth steps are 0. So till fifth step I am having the rewards as 0. So we need to calculate the reward at fifth step. Okay, and at the fifth step in the question it is given as 1. Therefore the discounted reward using the equation, using this equation is gt is equal to gamma of t plus 1 gamma into r of t plus 2 plus gamma square into r of t plus 3, or I can say summation of gamma r t plus j plus 1, where j ranges from 0 to infinity. Now they have given the discounted factor in the question as gamma as 0.7. So make it 0.7. I am collecting the rewards up to fifth step. So instead of so take it to the power of 5 into 1, where 1 is nothing but this r. Okay, so gamma value is 0.7 to the power of 5 because you are doing at fifth step, and r is 1. So the answer here in this case is 0.16807. So that's it for today's session. In the next session we will continue with the important algorithms of reinforcement learning. Thank you so much.